reason why students struggle so much with this topic is because they don't have a set process to follow. So what do I mean by that? Something you can follow like a robot. So step 1, do this. Step 2, do that. Step 3, get the final answer and get it correct every single time. Well, good news. Today I'm going to walk you through this process that you can use for any one of these questions and apply it every single time, whether you're dealing with calculations involving solids, liquids, or gases. And that's at GCSE level and beyond, whether you're going to do A-level chemistry, advanced placement, IB, whatever. Today's lesson underpins all of that. And I promise you, if you follow this process, you'll get the answer correct every single time. So before we start, the lesson example is attached in the description below. And as always, if you have any questions, please comment down below and I'll get back to help you. Otherwise, let's get into it. So, reacting mass questions, also known as molar ratio questions, are pretty much the cornerstone of chemical calculations that you'll come across in high school chemistry, GCSE chemistry and beyond, and pretty much underpin everything you'll do in regard to, to calculating masses of product or concentrations of product or, volumes of gas. All of these questions are solved using the same process. So once you've mastered this, they become pretty much, straightforward. They all read the same and they all sort of look the same. So before we look at the question here, which is on the Haber process, we're going to look at what I call the 3-point process, which you can use for all of these questions, and it works every single time. And it's pretty much idiot proof. You just follow the 3 steps and get the correct answer. So what does this look like? So here are the 3 steps you need to follow to work out reactive mass / molar ratio questions. And by the way, before I go through this is attached below the video, so please download it and use it to work out the question. So, number 1, look at the chemical equation and circle the 2 substances that are discussed in the question. The substance you are trying to work out, let's call it A, and the substance you are given information on, let's call it B. Then work out the moles of substance B. So in a question, you're always obviously asked to find something. So you have to circle that species, and then you will be given information on something else. And so that's the other thing you circle. Only 2 things you circle. Number 2, compare the molar ratio of the 2 substances that you've circled. So is it 1:1, 2:1, and so on? Use that molar ratio to work out the moles of the desired substance A, the one that is wanted in the question. And finally, step 3, once you have the moles of the substance that you need, you can turn that into a mass using moles equals mass of RFM, or a concentration, moles equals CV, or a gas, moles equals V over 24, or using the ideal gas equation, and work out what is asked for in the question. So, whatever's needed in the question, you use the appropriate moles formula, one for solids, the one for liquids, or one for gases. So let's put this into play with the question above. So step 1, circle the 2 things discussed in the question. So it says, what maximum mass of ammonia can be made when 11.2 grams of nitrogen reacts with excess hydrogen? So I've circled the nitrogen and I've circled the ammonia because the thing they want is ammonia and the thing that we have information on is nitrogen. So I'm using the word thing, just trying to keep this as basic and as straightforward and not complicate the language. So step 1, let's work out the moles. So moles of nitrogen. So it'll be moles is mass over RFM. So 11.2 divided by nitrogen N2 is 14 times 2. So 11.2 divide 28 gives us 0.4 moles. Notice that nitrogen is a diatomic, so just like oxygen, just like hydrogen, so that is why I've used 28 instead of 14. Number 2, what is the molar ratio of the two things that are circled? So you can see one lot of nitrogen produces 2 lots of ammonia, so it's 1 to 2. So therefore, the moles of NH3 will be 0.4 times 2 equals 0.8 moles. Finally, number 3, work out what is asked for in the question. So it is asking us for the maximum mass of ammonia. So I have the moles. So moles equals mass over RFM. So therefore mass equals moles times RFM. So it'll be 0.8 times the RFM of ammonia, which is 14 plus 3 lots of hydrogen. So 3 times 1 is 3, 17. So 0.8 times 17 gives us 13.6 grams. Notice I did not times the ammonia by 2 there. And the reason why is because once that molar ratio number or balancing number has been used in step 2, you cannot use it again. So you just, with the moles formulas, the gas one, the solids one, or the liquids one, you always use the RFM for 1 unit of that particular reactant. Okay, you ignore the balancing numbers. So we're producing 13.6 grams of ammonia. Right. What would happen if you was asked to find, say, the concentration of ammonia being produced, or the volume of ammonia being produced, if it was in the gas form or liquid form? Well, instead of using moles equals mass over RFM, you would use, for the liquids one, moles equals C times V. C for concentration, V for volume. Or for the gas formula, moles equals V over 24. In other words, once you get the moles of whatever you want, you can turn it into whatever unit is needed, whether it's mass, whether it's concentration, whether it's volume. So that is the beauty of converting things into moles, because you can work out whatever you like from it. Okay, so there is a follow-up video to this where I go through concentration examples and gas examples, so please go and check that out. Hope this one was useful, and I will see you in the next one.